Imagine a world where packages move fast, but the information about them moves even faster. But in reality, logistics systems are scattered. Different platforms, different protocols, different languages. In modern logistics, many systems need to communicate, but they were never designed to work together. This system heterogeneity creates communication barriers and makes integration complex. That's where Swift Logistics comes in. Swift Logistics solves this problem with a powerful middleware architecture. At the center is an ESB-like integration layer that acts as a bridge connecting all backend services. The platform is designed to scale with growing logistics demand while also enabling real-time data processing, ensuring that critical information is delivered instantly. Now let's dive into our newly proposed SwiftTrack platform.
This is the SwiftTrack customer web application. A new user can register by filling the sign up form. Returning customer can simply log in using their email and password. After logging in, we land on the main shop page. At the top, there is a banner highlighting current offers. The product displays a card for each item. To build an order, the customer can simply click the Add to Cart button on any product. The cart icon in the top navigation bar shows a live count of selected items. Clicking it takes us to the cart page. Here on the left, we can see a list of the items the customer has chosen. On the right is the order summary panel, which shows the subtotal and the final total. As I start typing in the address field, the Google Map autocomplete drop-down appears, restricted to address in Sri Lanka. Once I selected an address, the map below automatically zooms in and drops a pin at the exact location, allowing the customer to visually confirm the delivery spot. With the address confirmed, clicking the Place Order button submit everything. The My Orders page lists all the past orders for this customer with the newest one first. Below that, there is a horizontal progress timeline with 5 clear steps: order placed, processing, ready, on delivery, and delivered. Completed steps are highlighted in teal with a check mark. This gives the customer a simple at-a-glance view of exactly where their orders in the delivery process. Also, there is a section for delivery information and the section for order summary.
I will explain about the ESP of our system. ESP is the central communication hub of the and the backend talk through this service rather than direct talk with each other. It runs on port 8290 and implemented using Node.js and Express. Okay, there are three main legacy services in our system: CMS, Customer Management Service; WMS, Warehouse Management Service; ROS, Route Optimization Service. So in the CMS, which is the Customer Management Service, stores the customer data and communicates with SOAP XML legacy service. Communicate front end with this service. ESP acts as the middleware and converts HTTP request and wraps it to a SOAP based XML, then forward it to the CMS, and responds also forward into the front end as a REST HTTP request. And WMS, which is called warehouse management data. When customer want to need whether the ordered product has left the warehouse, the front end of the client made a request to the API gateway. Then the API gateway is communicate with this WMS system in its language TCP/IP. In the route optimization service, which is a service that is used to generate the route of the particular order of a client. When the driver mobile application needs the route of the particular order, it will request it from the ESP, and ESP forward it to ROS. It's a system which is work with the REST and HTTP request, but it goes through this ESP, and ESP forward it to the ROS. When the optimal route is calculated, it provides that route by the communication of ESP, and ESP forward it to the driver app. Apart from that, we implemented notification or authentication to our system using JWT, and ESP act as the middle layer for that system too. And apart from that, in addition, we used Google Maps API to integrate the seamless driver experience, and we implemented it to show the locations on the map so the drivers can smoothly navigate to clients who are ordered their products. And we use MongoDB as our central database to the system.
Our customer management system is a legacy software service running on Flask at port 8000. All requests into the system are SOAP-XML messages, and all responses are returned in SOAP-XML following traditional enterprise integration standards. The CMS handles core customer operations like it allows creating new customers, storing their details like name, email, phone, and address in MongoDB Atlas, and automatically detects their Sri Lankan discrete form, the address assigning latitude and longitude coordinates for deliveries. It also supports retrieving customer information, checking order history, and managing current locations, ensuring that all customer data is accurate and up to date. Now, on the order side, the CMS processes orders, verifies customers, manages order items, updates status, and provides delivery details. In our modern architecture, the ESB middleware connects the legacy CMS with newer microservices, translating REST requests from our fast API services and React frontends. The warehouse management system is responsible for handling warehouse operations such as processing orders, creating package status, and managing delivery progress. In our system, the warehouse management system is implemented as a Python TCP server and it runs on port 9999. Unlike other services that communicate using REST APIs, the warehouse management system uses the TCP IP protocol, which represents a legacy warehouse system. When a request comes to the system, first goes through the API gateway or ESP. The request is related to the warehouse processing. The ESP forward the request to the warehouse management system through a TCP IP connection. Once the warehouse management system receives the request, it processes the order information, updates the warehouse status such as ready, on delivery, or delivered, and manages them inside the warehouse management system.
The product service is responsible for managing all product-related data within the system. The service runs as an independent microservice developed using Node.js and Express, and it operates from the products module with the entry point located at server.js. By isolating product management into its own service, the system becomes easier to scale and maintain as the platform grows. The service runs on the base URL at the local host via the port 5999 and primarily interacts with a MongoDB database called product. In this database, two main collections are used. The items collection stores individual product records such as product name, category, price, and stock content. The second collection is offers, which stores promotional offers that can be displayed to customers. The product service has several key responsibilities. It serves the product catalog, the front end, and other services, allowing products to be filtered by category, searched using keywords, and limited by price ranges. It also provides promotional offers that can be displayed to users. In addition, the service supports basic inventory management. When an order is successfully placed, the system calls a dedicated endpoint to decrement the product stock count, ensuring inventory remains accurate. To support these features, the service exposes several REST APIs. Show product endpoint returns the product list with optional filters such as category, search terms, and price range. The categories endpoint returns all available product categories. Offers endpoint retrieves active promotional offers, while decrement count endpoint updates the stock quantity when a purchase is complete. Overall, the product service ensures that product data, offers, and inventory updates are handled efficiently, forming a key component of the platform backend architecture.
Now I will show the SwiftTrack drive portal. In here, we can simply log into our system. If you are not a registered user, you can create account in here. After signing, we land to our home page. In here, we can see the all recent activities what we have done. In this order part, we can simply accept our order. After the accepting our order, we can see that this accepted orders in this section, and we can simply start delivery. There is 7 on delivery activities. So after the delivery, we can mark as delivered. So there is our previous delivered activities. This route section, we can simply see that from the starting what we have to go one by one in our routing path. In this map also we can clearly see that section shows our notification, and all these notifications come through the ESB. We talk with ESB using JSON.